And off we go. Yeah, here we are, episode 10 of 10. Who would have thought that we actually make it through 10 episodes of the Devcom Tutorials coding for C++ in Unreal. No, coding Unreal in C++. Coding for Unreal. We do something in Unreal for Unreal with Unreal, and we've been using C++ quite a lot. The past 9 weeks, we've done... quite a lot of things. We've started with basically nothing. We talked about what are actors, why are actors, and how are actors. And we started looking at first, how do we make actors at all? And then how do we make them solely in C++? Because we finally decided, this is supposed to be a C++ tutorial. So why not make our actors completely in C++? Even I've also talked about why this is not practical, why usually you're not creating your actors completely in C++, but of course there's exceptions to the rule. There might be a lot of situations where you actually want to create your actor completely in C++. It all depends, it's the old thing. If you ask, how am I supposed to do this? Am I supposed to do it like this? Am I supposed to do it like that? The answer is always a very clear and precise, it depends. Yeah. So for the things we did, it was kind of impractical just to create them completely in C++, but since we wanted to look at how we do things in C++, so should we ever really need to do it, we at least know which episode to rewatch to see how it was done. And we talked a bit about actor components. So what's the difference when we create an actor? What's the difference when we create an actor component? What are components? How are components? And how do we get the components onto our actors? And even more importantly, how do we create them also, again, completely in C++? Which is, well, now you can do blueprint components. You can do blueprint components, and of course you can always mix and match your blueprints with your C++. This was another thing we looked at, and I see that I find one of the examples we had, because tonight I will be going with you through all the code, all the things we've made in the last 9 weeks, and there should be a few interesting things in there. If I don't find them, we'll just recreate them quickly from scratch. They are not that complicated. For example, I don't know, what was it? Our components, was it maybe here? Movement component. Because we had something where we created, and this is actually it. We created a component, and because we said you can mix and match your blueprints and your C++ stuff, which is usually what you want. I mean, usually, even if you, like me, you enjoy classic coding, and this is another thing. I've read this last week and this week, basically all the time. When people do blueprints, do I have a neat and tidy blueprint example somewhere here? What's that? Do we have some blueprint stuff? Yeah, look at that. I mean, nothing works because, I don't know, maybe we need to recompile, or we actually broke something. It's likely that during all our experiments we did break stuff, so that might not work. But excuse me. So this is basically this is our blueprint stuff, and people don't use this coding. And for me, in my opinion, and I would like to share that opinion with you, doing blueprints, doing all these little nodes and drawing all those lines and plugging stuff in and calling things, this is as much coding as this. Well, this is only header. Maybe this is actual code. This is classic code. This is, let me switch to the view a room with a view where you can actually see what I'm talking about. So this is the blueprint stuff we have in Unreal Engine. You don't have to do classic coding line by line, like, again, wrong window, like this one is. This is classic old school line by line coding. Some people are afraid of this and are like, oh god, this is so complicated, I will never understand this. And especially when it comes to C or C++. People know that C# is basically Java, and that's everything is super easy, and you can't really make things kaput, you know? You can't really destroy stuff, and nothing really bad happens. The worst thing that could happen to you is you get a red error message in your log. And maybe something that is supposed to do something doesn't do something. That's the worst that could happen to you. And if you do C# or the same goes with Java, etc. So people are more like, okay, yeah, I might try this. I can't really break stuff. But when it comes to C or C++, people are still like, oh boy, I can. Oh, this is so super complicated. This is. I'm afraid of this. Things break and nothing works. Well, yeah, you can. Now you can't really damage stuff, but of course, when something goes wrong in C or C++, the effects might be a bit more severe than just being like in C# with all the safety nets and everything. And hi, this is I thought I could set the font size a bit larger so I could actually see something from the distance on my little notebook display here, but well, the font size isn't big enough, at least for the old man that I am. Maybe I needed new glasses or something. But Denix, hi, how's it going? It's going pretty fine here. So just sliding into the evening and trying to summarize what we did the last 9 evenings at this time. On this day, well, not this particular day, not today, but the Thursday days, because we've spent 9 weeks, which is quite a time. This is today. It's 2.5 months, not 2.5 men. That's something completely different. It's only one man and his car trying to change the world for the better. No, that was something completely different again. So, yeah, 2.5 months. We've now spent every Thursday evening together, and for 1 month, for 4 of those 9 weeks, even the Wednesdays. So, yeah, we got used to each other, I think. Well, and there's so many things we talked about, and I was just rambling about people not calling Blueprint not calling this coding. I've read, it was earlier this week, I've read someone who did something in Blueprints and he was quite proud of it and it worked. And he was like, yeah, I didn't do classic, I didn't do any code, I just did Blueprints. And doing Blueprints is pretty much the very same thing as classic coding line by line. As I just said, many people are just a bit afraid, especially of C, because things can really break. If you have wrong pointers, or you forgot to initialize something, there's a few safety nets you do not have in C or C++ compared to almost all of the other languages, the higher level languages. But you get used to this. This is nothing to be afraid of. This is nothing that I don't know, makes things break. It might be a bit confusing, especially on C, where you have to initialize your variables yourself. This is another thing we talked about, because the C compiler, when it compiles your code, it only makes sure that there is a memory location somewhere in all the gigabytes and gigabytes of memory your computer might have. There is a very small spot that actually holds this one particular variable, that holds your value you put into this one. But that's it. It just takes care that there is a spot of memory that is dedicated to this value. It does not put any default value in there, which is something, if you come from a higher level language, like, again, almost all of them, even Go does this, But Go isn't that low level. Go is actually... Go tries to look like it's low level, but it's actually quite high level. Even though it tries to look like and behave like C, it's far from it. So yeah, you just got whatever is in that memory location from programs that run there before. So you have to make sure to initialize your variables yourself. I've also mentioned this already. This is our little game of life implementation we did, and we're also gonna be taking a closer look at this again tonight and see what we did and how we did these things. And I actually had this on the second evening when I wanted to continue with you guys working on this. I tried out that everything still works, because those of you with some coding experience know that if something worked yesterday, because this is cliche programmer slang. Yeah, it worked yesterday. I haven't changed anything. It worked yesterday. I have no idea why it doesn't work right now. So yeah, just because it worked yesterday or last week, I just wanted to make sure that everything worked. And it was a good thing I did that, because it didn't. It didn't work. I started a program and it looked like this. There was nothing there. It was supposed to look like, well, without the little wannabe Devcom logo there. It was supposed to look like this, but it did look like this. And then I looked at this list, and all the actors, they were there. And when I tried to focus on them, because Unreal has this very nice feature that many engines have. You can, like, if you double click on one of the actors that are listed here, or if you just have it selected either by the list or by clicking on it directly in the scene and you hit F, you're not only paying respects, but you're also focusing on this actor, which means the editor will move the editor camera close to the actor and rotate it, so you're actually looking directly at your actor or your object, whatever you've selected. And I did this. So I focused on one of the actors, and it was garbled. White noise back then when we had analog TVs and analog antennas and everything? And it didn't have any reception. You just got white noise, and this was exactly how my image looked. And I was like, what? And eventually I noticed in the transform here that the Z value, it was like, I don't know, I have no idea how many digits the number was, but it was a huge number. It was I don't know, 6 or 7 digits or so, a huge number in the Z value, which put the actors far outside of a range where the engine is still able to render things properly. So it kind of confused the engine. And why did this happen? Because I forgot to set Z to 0. It's not at 0 right now, which is kind of weird, but it's at something sensible. It's at minus 275. That's pretty okay. But they were completely off. They were off the chart because I forgot to set it intentionally to 0 to initialize it. The value was there. It was eventually used when spawning the actor, but I've never put the 0 in there, and that was bad because I got the aforementioned random thing that was left over from something else that was at a memory location. So this is something you just have to get used to. And if you have this kind of behavior, and once you've worked with C++ a bit and you actually got used to these behaviors, like, oh wait, where's there completely unexpected values in there? And this already hints you at this isn't properly initialized, and then you check and you see, I forget to set it to 0. And once you do this, everything works. So yeah, you got a few safety nets less and a bit less convenience, which in turn gives you more control over things. And you just, if you do this, if you just take up with it, you get used to it, and eventually it's a no deal for you. So okay, I forget to initialize this variable. I actually tried to do this deliberately. I think it was last week. I actually tried to do this. I tried to create a variable and not initialize it, but the compiler didn't let me compile because the compiler saw like, dude, that's not cool. That's not initialized. Please do initialize and then try again. So I don't know why the other time it didn't spot it, but yeah, this might happen. So, and this is nothing to be afraid of. But Denique says a question that's more about C++. When you use pointers. When do you use pointers and why? You've forgotten a lot about it. So yeah, cool. Because today I want to summarize and to go over everything we've talked about in the last 9 weeks. And we actually spent 2 whole evenings. And I think the second one even went into overtime because I wasn't done yet. And I didn't want to postpone that last bit I wanted to talk about to the next week. So we just went into some overtime. So we spent 2 whole evenings talking about pointers. So you might want to also check out the recordings of those streams. And just for total convenience sake, but I'm gonna be answering your question nonetheless. This is not like, no, I'm not answering this. Go watch the old recordings. Just mentioning they exist. Just for the case they might be of interest to you. So there's the link to the Devcom YouTube channel in the chat, which has all the recordings of everything we've did here archived for, I'd like to say eternity, but I don't know. I think the time will come, and even if it's in 500 years, the time will come when YouTube finally shuts down or loses all its data centers or the world burns down the fly. I don't know. So it might not be for eternity, but they are there for quite a while. And you can see it here. There's all, and I think they even, is this a play? Yeah, this is even a playlist. I mean, look at that. There's even a playlist that neatly contains all of the tutorial videos, so you can just pick out the ones you want. They are also properly named, so if you look for the pointer ones, it's this one. See, Unreal Engine pointers 1 of 2, pointers 2 of 2. So it's quite easy to find. But when do you use pointers and why? The when is quite easy. All the time. There is no way. There's literally no way around pointers. If you do C++, you will have to deal with pointers unless you do something that only handles with the primitive types like integers, bools, floats, and whatever. There's also one thing you don't especially need a pointer to, but sometimes you need to be pointed at because you might just monologuing away and I don't know, missing it, and this would be like greeting Dominic in the chat. He just came in and hi, a wonderful evening to you. Greetings. I hope you had a wonderful week so far. Only 1 day left till 2 days home office. Yay! After 5 days of office, there's 2 days of home office. And it's only, well, actually tomorrow is home office as well. We just decided on short notice that tomorrow we'll just be doing home office. My coworker said, look, I'd like to do home office tomorrow because reasons. And I was like, you're doing home office? And I'm almost alone. I asked the other one, are you here tomorrow? And he said, nah, maybe not. And I was like, okay, you know what? I'll be doing home office as well. So yeah, home office for everyone tomorrow. Sadie, hi, a wonderful evening to you. Greetings, and nice for you to stop by. Hi. So yeah, pointers. When do you use them and why? When is basically all the time, and the why is this is also something. If you're really interested in the nitty-gritty details and in the sometimes, well, because I noticed there's one thing that's even harder than understanding pointers, which is trying to explain them. So I hope I managed to somewhat explain stuff and maybe actually get rid of some of the confusions and some of the questions. So, well, feel free if you should happen to rewatch the old episodes about pointers and there is something that's not completely clear to you, please just shoot me a message. There's the Twitter handles down there. Each one of them, pick whichever you like more. The first one is my personal Twitter account. The second one is the Twitter account of our studio. Just shoot me a message, or if you're on the Devcom Discord, I'm there as well. Whatever you like, just shoot me a message if anything's unclear, and I'd be more than happy to keep talking about this. So, yeah. Long story short, the thing is we only can have stuff as an actual variable, an actual value that's a variable that fits into a CPU register. Yeah. Sounds weird. And I hope I managed to explain this a bit. So there's not much we can actually have in a variable, because in C++ or plain C, doesn't matter, it's the same with both. They are very, very, very close to the actual machine. So the code you write, this, in a way, is actually seen by the CPU. Whatever you put in here is seen by the CPU. The actual processor, the thing, your Intel Core whatever, or your AMD Ryzen or Threadripper or whoever else you have in your machine, will see this pretty much exactly the way you typed it here. Maybe with a few changes, because the compiler thinks he's clever and he likes to optimize things and to shuffle around things. And sometimes when you're dealing with structs, change things without you knowing, but in the end, everything works like you expect it to do. And this is the reason why we just can't have the primitive types. We can have integers and floats and booleans and all the tiny stuff. We can have that as an actual value in our variable. Anything else that's bigger, like the prime example for when you use pointers is like this one. When you're dealing with objects, which in C++ you do a lot, because C++ is object oriented. So you're dealing a lot with objects. So when we deal with objects, we basically all the time, we really all the time have to deal with pointers, because an object is too large to be a value in itself. So the object has to be stored somewhere in memory. Maybe the computer didn't like me saying gigabytes. Maybe I shouldn't do this anymore. Maybe the computer was like, dude, no, stop it, or I'll stop. I don't know. Yeah. So your many gigabytes of memory, the objects have to be stored somewhere in there, and the actual value that sits in your variable is the memory address of where that thing is stored. So imagine your memory like this huge shelf with all those drawers in there, and the computer deciding, yeah, you know what, the drawer 42 over there, that one, that's the one where I will be storing the data of your object in. So it puts everything in, and the drawer sits neat and tidy on the shelf. So what's actually stored in your variable is the 42, because that's the number, that's the address, that's the information in which of all those drawers, of all those millions and millions of shelves and drawers you have in your memory, which one has the one with the data you want. And if you want to access this, so if you just access, this is what the this asterisk thingy there states. This means this is not a value in itself, but this is the location in memory where this value, or where everything that belongs to this value is stored. I don't know, something flying around here. So this is where this value is actually stored, and this is what this asterisk sign tells the compiler. So whenever we access this owner variable, we're not accessing the actual value of what we're storing, but the address of where that stuff is stored. And then we of course we have ways to actually then access what the actual value, like this arrow thing here, which is a shorthand. This is also something we covered. The arrow is a shorthand. So another way of writing this would be like this. These two lines are absolutely identical. They are so identical that during compile time, when the compiler turns your neat and tidy English words into actual machine code, the compiler will compile this as if you would have written this. The arrow thingy is only a convenience thing that was implemented for lazy people like us programmers to be a bit more convenient, because this is not only hard to read, it's also so much to type. What this does is, remember, we have I'll put a few more spaces in there so we can look at different things. Remember, this owner thingy here was declared with the asterisk. So the variable called owner, there's not a value in there, but the address in memory where all the contents of this value are stored. And if we put this asterisk again, because up here, this is also a bit confusing, but if you write it like this, or this, or this, or even this, it doesn't matter. It really, really doesn't matter. Let's scrap that part. Maybe let's put it more specific so we can see the differences a bit more closely. So it really doesn't matter where you put the asterisk sign. If you put it as a suffix for the type, or as a prefix for your variable name, or just stand alone in the middle of them two, doesn't matter. It's the very same thing. And also, if you say, yeah, this is a pointer to this type, and we call it like this, or if you say, yeah, I have this type, and this is a pointer to it, it's the very same thing. The compiler and the computer they don't care. The effect is the very same. I personally, and this is only my personal preference, and if you like to do it any other way, that's perfectly fine as well. I personally like to do it this way, because I think the pointer is part of the type definition. We're still live, right? Yeah, still working. Okay, cool. Just checking. Just checking. Let's see how often that thing breaks down. And the problem is I have no idea why. It used to make weird noises, and it stopped making the noises, and instead of making the noise, it just breaks down. I have no idea why. So this is an F vector, and for me, if it's a pointer or not is part of the type. So this variable holds something that is of the type A-actor pointer, or a pointer to an A-actor object. And if you write it this way, the line down here becomes a bit more clearer, because this basically says, okay, we're storing an A-actor, which is the actor object of Unreal. And this is our variable, but our variable is a pointer and not the actual value. So if we put the asterisk in front of it again here, this is called dereferencing the pointer. Which is weird, because we're actually referencing, I've never understood how that name came to be, because we're actually referencing the contents at the address, the point. Well, I don't know. They just call it this. Don't ask me why. They decided this is called like this. So we're going to be calling this like this. So if I wouldn't have the asterisk here, I would access as, I think you know what I mean when I say as a value the address. So if I just write my variable name, I get the address of where my object in memory is. But if I actually want to access this address, I again, is similar to up here, I just put the asterisk back in front of my variable name, which means, okay, in this variable, I do have the address. I know where something in memory is. And because I put the asterisk in front of it, I tell the compiler, and now I want to access this. I want to access this memory location. And this gives us an object of the type AActor, because that is what's stored at this location. We then just have to put the brackets around it, because if we would not do this, if I would do it like this, this would not work, because precedence of the order in which things are evaluated. It's like back in, I don't know, 4th grade, 3rd grade, 2nd grade school math, where we learned that if you have 1 plus 2 multiplied by 3, you first have to do the multiplication. You first do the 2 multiplied by 3, and then you have the 1 plus part. If you want it any other way, you have to put brackets around it to force a certain order in which things are done. And this is the very same thing. If we do not use the brackets, this part, the compiler will first try to evaluate this. It will first try to access this method or property or whatever you have there from whatever is stored in this variable, and then it will use this as an address to access something, which will fail. Because this is only a pointer, and you're trying to... It's like trying to call a method on a number, which you can't do. You only can call methods on an object. So this won't work, because the compiler will first evaluate this, and when it's done with this, it will apply the asterisk. So the pointer dereferencing. Let's go with dereferencation. That's a nice word. I think we created a new word. This seems to be to become a thing of the Devcom channel. We create new words here. Dereferencation. That sounds nice. Let's go with that. And so we don't want this. What we want is we want a dereferencation of this owner variable, and whatever results in this, we want to call a method on. So this is why we have to use those brackets around it to tell the compiler, look, this is our variable, and we want to access what's ever stored on this. And then only of what that the result of what that gives us, then we want to call this method on. So this is what actually happens when you write it like this, and this is how you access the values of pointers. And do we have... Wait, I mean, we did pointer stuff. Look, we did pointer stuff here. And we even did here. Look at that. I mean, it's commented out because we tried different things, but it's still there. We have this, where we have b. b is a pointer variable. It's in this case, it's a... look at that. We've even written it like this with the asterisk in front of the b. So this is a pointer to a simple integer, a 32-bit integer, but it's the pointer to one. This is not the value. This is not an integer. This is the address in memory where a 32-bit large number is stored. And then we just put an asterisk in front of the b because we want to explicitly access this memory location and put a 7 in there. And by coincidence, what we did here is we put the address of our A. This is another pointer thing. This is the ampersand sign. That's the second important, thing. What you call them? Qualifiers. When it comes to pointers, because look at our definition up here. A is just a is just a simple 32-bit integer. A is just a number. B is the memory location where a number is stored. And if we put an ampersand in front of our variables, we actually get the address where this value is stored. So ampersand A is pretty much the very same like this definition up here. A is just any number. In this case, it's 4. It's the value 4. And ampersand A is the memory address where this 4 is stored in memory. And since our B variable is declared as a pointer to where a value is stored, we can just assign B to the address of A. Works perfectly fine. Which means that those two addresses are the same. Well, if you have 2 sheets of paper, the one is blank and the other one has the address of your best friend. Like, I don't know, hometown 3255 Middle Street, whatever. And you take your pen and you copy, you write whatever, the address that's written on your one sheet of paper, you write the same address on your second sheet of paper. Then you have 2 sheets of paper, but they both tell you the same address, which is exactly what happens here. So this points to the very same address as this. So it's only logical that if I write something at the address stored in here, and then I access whatever is stored at the address of this one, since the addresses are the same, whatever I put in here, I can read from there. And this is why when we access the memory location B is pointing, hence the name pointer, the memory location where B is pointing us to, if we put a 7 in there, but we then print the value of A, we actually get the 7 and not the 4 from up here. Because since, again, the addresses that are pointed to by B and A, that the addresses where they are stored, the values are stored are the same, we can do this. And we also talked about passing things by reference, where this is actually, where it's this one, it's the one with the ampersand. And this is also, we come back to this when we take another look at how you can call or how you can make your C++ functions being callable from blueprints. Because sometimes you want to give a return value, and with blueprints you can't just, like from any other method, you can't just say return value and return this as a return value. This is why in Unreal you see that most of the functions are just void, so they are not returning anything. And then you have something like this. Well, this is the ugliest of all examples we can have, because this returns the address of an address. Yeah. It's just getting worse from there. it's just getting worse from there. But if you think about it, if you take a deep breath, and I think after those 2 evenings of talking about pointers, this doesn't look that shocking anymore, and I hope we understand and know what's actually happening there. So we'll be given a variable in here, but we'll be given not the value of this variable. We'll be given the address of this variable. So when we put something in there, when we put something into this variable, we're actually putting it at the address where the variable was of whoever's calling this method. In this case, it's actually this one. So we have our variable up here, some object, and we initialize this with a null pointer. So it points to nowhere. There's literally null, a absolute 0 value in there. And we call this method and we give it this variable. And usually when you call another method or a function and you pass a variable as a parameter, you're not actually passing your variable through. You're only passing a copy of the value, usually. Like, I don't know, do I have any other? Yeah, maybe with this print thing here. Usually when you call a function or a method and you pass your variable as a parameter, what happens in the background is the computer will read out the value that's stored in your variable and will pass a copy of this value, completely separated and independent from your original variable, as the value that's passed for the other method or the other function, so it can then use this value and do with it whatever it's doing. In this case, if you put the ampersand in front of the parameter variable, you're not passing a copy of the value. You are actually passing your variable, or at least the address of your variable in there. So these two things, these behave like this ampersand the object and this some object variable. Those are two variables, different names. They look like they're completely independent and have nothing to do with each other, but they actually behave exactly like what we did up here with the B and the address of A. B was a pointer to an address, and ampersand A is a pointer to the address where the value of A is stored, and we just copied this address over into this variable so we could access the same memory location using both variables. And this is exactly what happens here. So this means if the location in memory of this variable and this variable are the same, that means if I write a value into this variable inside this method, like I'm doing here, whatever I put in here can be read down here, since some object and the object, those two variables, they point to the very same memory location. So whatever I'm putting in here, when this method is over and control is given back to this method that was calling this one, after this call, the variable some object has the contents of whatever I put into the object down here. And so I can access this. So this is another way of passing return values, of giving something back. Because, you can't just take and take and take. Sometimes you have to give back. And this is used when you're using blueprints. This is the way you pass return values back into your blueprints. And this is the only way. You can't use the normal return values. This won't work. I don't know, for implementation reasons, this is the way they did it. And also, this is also the reason why I like using this there's two reasons why I like doing my return values like this. Because the one reason is doing it like this, you always have the option of making your function, your method callable from a blueprint without having to touch and change it. Because if this would have been more like this, if this would look like this, and instead of this we have the return new object. So in pure C++, this works perfectly fine. You can return whatever you're getting back here. You can return this as a return value for this, and then we would just, in this case, we would have, up here, we would have said some object equals make object, and then just nothing passed. So this one would call this one, and it would inside C++, this would work perfectly fine. But you can't use this method from a blueprint. There's no way you can make this without changing it. Without changing it, there's no way you can make this work in a blueprint, because blueprints can't use these return values. They only use those. So if for whatever reason, later down the road, you decide, damn, I actually want this to be called, I want to call this from a blueprint. You have two options. You can make a so-called wrapper function, which basically only calls this one. The function selber, sorry for mixing up the languages. The function itself doesn't have any logic to it. All it does is it calls this one and then returns the return value in a way that works for the blueprint, or you have to actually change this. You have to say, okay, you know what, make this void, put this in here as a variable, which gives you this up here. But you have to change this, and if you change it, you risk breaking other pieces of code that expect this method to be the old way. So you don't want to change it. You have to make a wrapper function, which is a huge mess. If you do this many times and you have many wrapper functions, it's a mess. It's really not nice. And you will slowly realize why you do not want this. So this is why I tend to always return my return values like this, because to make this being able to be called from a blueprint, I have nothing to do to the method itself. All I have to do is to go into the header, put this ufunction blueprint callable thing in front of the definition of my function, and that's it. If I, for whatever reason down the road, I decide, I actually want to call this, here it is. Right now, it can't be called from a blueprint. It's not visible to blueprints. But the way this is written, with this type, with this version of giving the return value back, all I have to do is to copy paste the ufunction blueprint callable in front of it and be done. This is it. Now this method is perfectly fine, usable from a blueprint, just the very same way I would use this from any other C++ code that might want to call this. So this is one reason why I like to always do it this way. Let me just undo all the changes to keep this neat and tidy. And the second reason is, this way you're not restricted to one return value, because if you do the classic way, instead of the void, you define your return type and then you do return whatever. You have one value you can return, and that's it. You can make it an array. Yes, you can put more values into it if you have an array. But I personally don't like using array when it's actually multiple separate values I want to return. You have an array if there's many values of the same type. Like, I don't know, give me all the objects that match to a certain that match something. Then you have a list of objects, an array of objects. That's okay, having an array of this. But I don't know. I want to return the temperature, the humidity, and the chance of rain. For me personally, that's not an array. You could do it as an array, or maybe a map or a dictionary would be more appropriate. But you could also just make more of these. What you could have is, I don't know. You could have an integer for the temperature, and of course you have to put the ampersand in front of it, and then you can have another integer for, I don't know, chance of rain. Let's make this CRR because I'm just too lazy to type more. And humidity. Let's just call this H. I don't know. So this way you can neatly return 3 different values that don't really have that much to do with each other. And it's a bit more clear, like, okay, here you're returning this, and there you're returning this, and there you're returning that. And there was also another question that actually came in from one of you guys, which was very, very good, because this pointed us, no pun intended, to another, let's say, I don't know, this is another integer, this is the location ID, So this does not have an ampersand. So this is passed by value. The method only gets the value of this and not the location of your variable. So this is just a value, like we're used to, like all the other times. And this is what gets returned because of whatever our method did with the location ID we gave it. And this is already for someone who spent 2 evenings with us talking about pointers. They know, look at this. This is kind of like an input, and these 3 are kind of like outputs, because this is given in, and this value only exists within this method. But whatever it's put in there is also available to the function or the piece of code that actually called this. And another nice thing you can do is you can actually decorate this. You can actually say, look, this is an input. You can put an in front of this, or this is an output. You can put the out in front of this, because we looked at this when we were talking about defines. Well, actually, this was why we started talking about defines in the first place. During compile time, these are completely stripped out and replaced by pure nothingness. So for the compiler, when it compiles your code, if you put these in or not, same result. For the compiler will actually see this as this. The compiler won't even see these things. They are completely, they won't exist when the compiler sees your code and does stuff with it. The compiler will see it like this. So if you put them there or not, for the code, for the machine, for the compiler and the computer, it absolutely doesn't matter if you put them there or not. But for you or any other human being that might look at your code, these are quite handy, especially if you make it really, really tidy and you put another space in there. Because now it's really clear. This is an input to this method. This is a value I'm giving in to this method so it can do things with it. And these are outputs. They are usually not values this method uses and does things with them. It stores its return results in there. Yeah, and this is quite handy. This is quite neat. And I was quite happy that the question pointed to these things, because they make code a bit more readable for us puny humans. The computer doesn't matter. The computer doesn't care. He knows what you mean. But we puny humans, we might have, especially when it comes to this pointer, these ampersand things, we puny humans might have a little problem thinking like, okay, well, what is that? Why is that? Why does it work? Why do things actually work? I have no idea. And if you put those in front of there, it's at least a bit more clear. So yeah, those are the 2 reasons why I personally like doing it this way, because my methods are automatically blueprint compatible should I ever want to call them from blueprints, and I can pass more than just one of the return values. Yeah. And the blueprint thing, actually, this is one of the reasons why I like working with Unreal Engine so much. Because the way you can combine all the blueprint stuff and all your C++ code, I think it really shows its strength when you actually do this. When you have bits of blueprint, because either they are just convenient to do it like this, or maybe you have your artist who doesn't need to know classic coding line by line. But in the blueprints, he can change a few things and it's comfortable for him and everything's nice. You can still make up your highly sophisticated and super complex C++ code, and you can just expose this to the blueprints. So your artist, whenever he wants your super sophisticated code to do whatever it does, he just can drag in a node, put a wire into it, and just have your code being executed. So I really like this. And yeah, this is why I like it, because I like it. Does that make sense? Yeah, I hope so. Yeah, so I hope, again, the only thing that's more complicated than understanding pointers is trying to explain them. I hope this at least a bit clears up the question, how do we use pointers and why do we use pointers? We basically use them for anything that's not just a simple number, and we do this because of technical reasons that have to do with how low level C actually is. And so we use pointers, so we have our huge objects and all the amounts of data we got somewhere, we just know where it is and then we can access it. Yeah, so that was a bit of remembrance of all the pointer stuff we talked about. And if you look at this, at first this looks like super scary because you got them both. Usually when you just see the asterisk or just see the ampersand, you're already, oh boy, this is gonna make my brain melt. And now you got them both at the same time. Can it get any worse? I'm pretty sure it can. But if we think about the things that we talked about and we summarized again today, this starts to make sense and shouldn't be that scary anymore. We know that, okay, this is a variable. Disregard the ampersand stuff for a moment. This is just a variable. And this variable, it holds the address of something in memory, hence the asterisk. And whatever is there at this memory location is of this type. It's of the type use some class. This could be anything. This could be an actor. This could be a component. This could be a Schnitzelsalat, or maybe a Salat Schnitzel. If you're vegetarian, you can use this, no problem. So yeah, we have something. We have an object of this class, and we just have the address of the object. Should be pretty used to this by now. Yeah, this is cool. Okay, we got the address of it. It's somewhere in the memory. And then we got this variable passed in. But we're not getting the value, so we're not getting the address we're storing here. We want to return it because of the ampersand. So we're only getting the address of where the other function that called us stores its variable. So when we put something into here, we actually put something into the variable of the function that did call us. And all of a sudden, this address of an address isn't all that scary anymore, because if you take a deep breath and think about it, it starts making sense. And you say, okay, this is that. It works like this. And this is just the address of something else. And we just put this into that. And because of this, it's accessible from there. And everything's cool. At least, I hope we made it to this point where this isn't that scary anymore. And you say, ha, yeah, I know that. That's easy. It's absolutely clear. If not, again, I can only ask you if there's still anything that's not totally clear, just please ask. There's no stupid question. The only stupid question is the one not being asked. And even if this tutorial series is coming to an end, and I won't be here anymore every Tuesday talking about these stuff, the Twitter handles down there, they still exist. I'm still at the Devcom Discord server. So just shoot me a line, ask, and you shall be answered. Yeah, so we did talk about this for 2 whole evenings. We talked about the pointer stuff. And before we talked about this, we talked a bit more. We actually used them before we started talking about pointers and how they work and why they work and why they make your brain hurt. We actually started using them. This is the wrong window. Once again, I still need to stay in this one. I'm not sure. I think I started labeling these by date later on. But we have, I think we started, when we started out, the first thing was, oh, look at that. There's still crap I put in there to show you stuff. We started making a component, and I think this one even, this is our moving component. Maybe I find where we actually put it. because I think we made this callable from the blueprint, so we actually demonstrated this. You just have to put this in front of there, and you can call your stuff. Hey, Monogenesis! Hi there. Yes, I still stream, even though my stream PC almost went up in smokes tonight. So, pulling the plug and replugging the plug seems to have fixed it for now. So, yeah, we're back on live for now. Let's see for how long. I got the feeling that thing's not sure how long that thing will stay alive. And more important, which of all those components is actually broken? Because I don't know. I have no idea. I would need replacement parts to figure that out. I don't have replacement parts. Anyways, so yeah, here we are. And hi, a wonderful evening to you. Nice for you to stop by. And we're just summarizing and thinking about all the things we did, because 9 weeks. The past 9 weeks, almost 2.5 months. This is today. It's actually 2.5 months anniversary. We've been talking about coding for Unreal Engine in C++, and we had so much fun, or at least we all did. I definitely did, and since some of you even came back the next week, I suppose it wasn't that bad for you as well. So yeah. And because this is the final episode of this series, but who knows? Maybe we get a second season. Let's see. Maybe we get a different show, or maybe we get, I don't know. I do have a feeling that it won't be too long till we see each other again on this channel. I mean, you can of course see me on my channel. My Twitch channel is, by the way, the very same as my Twitter handle. Just replace the ad there. Let me try if I manage to point perfectly at the end. Just replace the ad with twitch.tv/, and you're also at my Twitch channel, and you're of course very welcome there. I don't do always. I do dev streams there as well, but sometimes when I'm just in the mood to play some games, I'm actually playing games instead of making them. Usually I'm making them instead of playing them, but sometimes I'm playing them instead of making them. A little great journey. Yeah, absolutely. Those last 10 weeks have been a blast. Really so much fun. Yeah. So, what did we do? Yeah, we had our little component here. We were talking about this. I think this was one of the first sessions we made where we just got started. And the way I usually do when I have C++ code and I want this code in my game to run and do stuff, I usually have my code, almost all of my code is in so-called actor components. We talked about what is an actor component. An actor component is basically it's an object with many methods and functions you can call, and you slap this onto your actor. For those of you who have some experience in Unity, it's the very same thing. They are called components there as well. So you have all your little neat methods, and once you slap your component onto your actor, this component will be available. There is an individual instance of this class for each actor you have your component slapped onto, and it has its own instance of your class and can then call all these things. Or if you use the tick function up here, which by default is called every frame, you can also do things there. And if you try to call them, this is let me close. Let me try if I find one that might work. Maybe it's somewhere here. Our first actor, maybe it's there. Yeah, that looks good. Look at this. This looks good. No idea why this is so far there, but you see, target I hope you can see this. Let me still magnify this a bit. It says set movement, which is the name of the function, and the target is moving component. And if I remember correctly, this is, look at that, this is our moving component, because we slapped this onto our actor, which is the wrong window, which is here. There it is. It just says moving, because besides saying hi to Lakeside, hi, greetings go out to you. Unreal is so clever knowing that this is in components, so it strips the component suffix from your name. But if we hover over this, we actually see it tells us the whole name moving component. But so these lists are a bit more tidy and a bit more readable for us puny humans again. It just strips the component name. And this is the thing we talked, I think, last week when we talked about best practices or good practices. You should always suffix your things. Like when you make an actor, call this some cool actor. If you create an actor component that you want to put onto your actor so your actor can then do stuff with it, call it my super duper cool component. So that when you look at your files, you immediately know what's in there. So if you look for an actor you've done a while ago, you don't have to look into the files that are suffixed with component. You completely miss time. Well, happens. We had a few meetings today that kind of screwed up my timing as well, and well, some other small stuff happened that I don't have to bore you with. So it happens. It's called real life. I know it sucks. We should have less of that. It always gets in the way. The real life. So yeah, here we have our moving component, and as you can see, we're calling from this moving component. We call the set movement thingy, which let me see if I can hit the right window the very first time. See, here's our set movement, and it gets two parameters, the x and the y, and right window again. Nice. And here is the two values we put in there. So this is usually how I do it, because this is the most convenient way. I just create the actors as blueprints, because we've also done this. We've created actors completely in C++. Let me see. Oh, I think we did this in the we did this in the Game of Life thingy that we're going to be taking a closer look at as well. So when you create an actor in Blueprints, basically all you have to do is right-click New Actor, give this thing a name, and that's it. You have your actor. It's completely initially, you're all there. You can add your meshes. You just say Add Component. You go into the viewport, and you say Add Component, and you use this you pick the static mesh component, and then you get this one, and you just select the mesh you wanted to display. And all of a sudden, your actor looks like something. And it's cool. Everything's nice. It's looking, and it's just there, and it does things. And if you want to have your moving, like your custom components on there, you again just say Add Component. You pick your component from here, and then you get it into the list, and you can drag this out, and you can just say, I want to call a function and see, here's the set movement again. Super easy, super convenient, and that's the thing. Don't be afraid of using this. And this is something I wanted to ramble about at the very beginning, when I then started talking about other stuff. Because there's people who say, yeah, I didn't do any actual coding, I just used blueprints. That's crap. If you're doing blueprints, you're coding. If you're doing this, you're coding pretty much the same as the coder guy who codes like this. Because, at least in my opinion, and maybe if you have a different opinion on this, please do share. But in my opinion, the actual coding is not writing down those lines. Because to be able to write down those lines, you have to know what you want to tell the computer to do. And the actual act of coding is coming up with the logic, with what is the computer supposed to do in which order. That is what's coding. The rest is just formulating this out in some language of your choosing. It's like when you want to wish someone a nice evening, like just right now. Lakeside comes in, and I want to say, "Hey, nice evening to you." I know what I want to say. I know that I want to say that this person. I want to say hello. I want to greet this person, and I want to wish the person that. It has just a nice evening. So this is what I want to say. And then I just have to translate this. I just have to formulate this out in a language that I understand and the other person understands. In this case, on this channel, mostly English. I could have also said it in German. Perfectly fine. We would have both understood. But the actual message, what I wanted to say, would have been the same. No matter if I say it in English, in German, or if I'd be able to in French, Russian, Dutch, or what I don't know. I need to know what I want to say before I can say it in any language. No matter how good I am in English or in German, if I have no idea what to say, knowing the language doesn't help me. So, and this is actually what, in my opinion, is the actual act of coding. So, someone who's doing blueprints is coding pretty much the same like someone who's just writing it line by line by line. It's just a different language. But coming up with the logic, with what has the computer do, and let me show you something. Let me just open up our actual project from work for a second. And then you will see that doing blueprints, because there is one example, we have to tidy it up a bit, but not sure if maybe we even port this to C++, just for, I don't know, but maybe not. Let me just, I think it's the player pawn. All right, yeah. I mean, look at this. There's quite a lot of stuff going on there. There's so much stuff going on there. I can't even fit this onto one screen. I mean, look at it. This is maximum zoom level. There's stuff down here, and there's a lot of stuff up here. And if I zoom in here, there's quite a lot of decisions that been made and stuff that's being done. And look at this. And now tell me this is not coding. Because coming up with this, coming up with the logic, coming up with all this logic, like I have to fetch this value and then I have to feed this into this, and I have to make decisions here. If I do this or that, and then I can do this, and then this happens, and then will trigger this, and at the end something happens and does something. This is actually the controls. If you move the playfield around, this is actually what happens then. So coming up with this logic, that's the actual programming part. And if you formulate this out, if you formulate this logic out in blueprints, or if you formulate this out in pure code, it's just the difference of saying hello in English or in German or in Dutch or whatever. You will hear it in Dutch. In Durch. Durch? Dutch? Yeah, I can't speak Dutch. I like hearing it because it's funny. Remembers me at... I played God of War 3. I think it was it was God of War 3. I played God of War 3 on the stream. And the first evening I went through the settings because my games and my computer, everything by default is in English. And since my stream usually is in German, I wanted to set the game to German language for so everyone can actually understand what's being said. And I was browsing through the language options, and we eventually came across Dutch. I was looking for German, but we came across Dutch. And the Ted and I, we decided, you know what? Just for the lols, let's try Dutch. Let's see how Kratos the Mighty. Let's see how he sounds in Dutch. I ended up playing the whole game with Dutch voiceovers because the chat, as much as we laughed it so much. It was so much fun. It was so funny, and I'm not meaning this in a bad way. So please, if there's any Dutch people seeing this, please, I beg you, don't get me wrong. I'm not laughing about you. I'm laughing with you. But for us Germans, especially like Kratos, when he was in this one scene where he found the girl that was not his daughter. I'm not sure. I forgot who the character was. Anyways, and he asked her, like, you're not my daughter or something, and she was, nay. And this is actually the way they say no, which I don't know. I'm very sorry if anybody. I hope nobody feels offended because of this. It's really just it was nice. It was so good. So I ended up playing the whole game in Dutch because I'm so sorry for us Germans. It's just sounds funny and entertaining, and it's just lovely. It's nice. So please forgive me if you might feel offended by this. If you do, let me know. And the next beer's on me. So sorry, but I hope we can still all be friends because it was just nice. So Dutch would be quite nice. For some people, this might actually look like Dutch, and this might look like, I don't know, maybe a plan for the subway. This is maybe this is. This is the plan where the subways, not the sandwich making subways, but the subways to travel with from A to B. Yeah. This is interesting. You can. I didn't know you could do this. You can merge multiple lines into one. This is. Oh yes, now of course you can do because the execution you can trigger. Yeah, no, okay. Now I didn't know this. Yeah, makes sense. See, Lakeside loves the Dutch language. Yeah. And the funny thing is, I even kind of understand it. And I always have an idea of what the person is trying to say. Even if I don't know the language. I really don't. But there's so many familiar parts. There's some words just sound similar enough to something you know that you know what you have a pretty good idea of what the person is trying to tell you, which is amazing. Because I think Dutch people are the ones with the least problems of communicating around the world. Because no matter where they are always somewhat understood. Maybe not completely, but somewhat. You always have kind of an idea what the person is trying to tell you. Yeah, not to mention it's a lovely, geographically it's a lovely area. When I still lived at my parents', we actually made weekend trips, family weekend trips to the Netherlands or Dutchland. I'm not sure how you actually are supposed to call it. So yeah, we made weekend trips, or maybe long weekends from Friday to Monday or something, to the Netherlands. And just love it there. It's so nice, and I don't know, maybe my parents just always picked the right spots, but everything I've seen so far from the Netherlands, I loved it. It was so great. Such a lovely country, and beaches and all that. All the places we were, they were just great. Yeah, I loved it, and I think I need to. When the current pandemic situation is over and you're actually kind of safe traveling again, I should do a long weekend, like Friday to Monday. And I don't know, get myself a nice bungalow and just spend the weekend there and just enjoy everything. Yeah. Sounds like a plan. I will do this. So why do I have... Oh, look at that. We can close this one. And then we got... Okay, this is very lonely. So this is not so lonely. So yeah, anyways. If you do coding in Blueprints, or if you do coding in classic, in even hardcore C++, I think the actual act of coding is very much the same. And while in Blueprints it's very easy, you just say, you just hit the right mouse button and just say, look at that, I want to create a new blueprint class. You click on actor and bam, there you go, and you got like this, and you can put your blueprints in there. You can put your components on there, you can put your meshes in there, and it's super easy, super convenient. Within a minute, you got a complete actor created with how it's supposed to look, and all the colors and all the components with all the actual magic that makes the actor making something. This is something I wanted to demonstrate, and because we said, okay, we want to do this completely in C++, so we did it for our Game of Life implementation, and it looks like this. This is the same thing. This is creating an actor, which when you just use a blueprint as a blueprint actor as base for your actors or whatever you're going to build. If you really want to do this completely in C++, avoiding any blueprinting, it's way more work. Because you have to do everything, and I really mean everything, by hand. First you have to create an empty root component. You have to actually create the object for the static mesh component. You have to create this object yourself, and then you actually have to fetch your assets with references to them, and this is hard-coded stuff. And hard-coded stuff, we talked about this last week when talking best practice or good practice. Hard-coded things are never good. Hard-coded stuff should be avoided at all costs. Well, you can put this into some place where you can edit in the editor. Still, you have to create a proper object for your asset, or in this case, your static mesh you want to use. And then you have to set your static mesh object into your static mesh component, and you have to do everything just by hand. And is there performance difference between C++ and Blueprints? In general, yes. Well, in general, yes, there is. Of course, Blueprints they add a bit of overhead, because the things you do there. Let me open this one just for looking at its sake, because these things they have to be interpreted and translated into code, but they did quite a lot of this. So the performance penalty for using Blueprints, it's not that much anymore. It actually got quite less. I haven't done actual comparisons. Maybe there's actual comparisons on the web. But yes, saying it's completely the same would be wrong. It's not the case. But the performance hit when you use Blueprints, it's not that big anymore. Maybe we should try this. Maybe we should actually just try this. Maybe we create a blueprint actor and a C++ actor, and we spawn like 1 million of them. First we spawn 1 million of the blueprint actors, and we look at our frame rate. And then we only create 1 million of C++ actors and see if there's any difference in the frame rate. This would actually be a quite interesting experiment. Not sure if we could. Can we do this? Maybe we do this tonight. Let's keep this in mind. Maybe we do this. Most of the things that need to be done, because all these colorful nodes, they have to be translated into actual code that's being executed. But most of this is being done when you hit the compile button up here. When you hit the compile button, these nodes are actually translated into actual functions, into actual internal C++ code. Or existing code is just being called for each and every node. But still, there's a bit of an overhead. Yes, there's a bit of an overhead. But it would be actually quite interesting to benchmark this. This might be this might be a reason why you might do it by hand. But the problem is, if you do it by hand, you have to do everything by hand. There's no convenience whatsoever. Each and every tiny little bit you want to change with your actor, you have to do it in your code. But then again, if this gives you like a huge performance boost, it might be worth it. Maybe we actually try this. This is very interesting because now I want to know. Yeah, I think we're gonna try this. Yeah, we definitely should. So, level of detail. That's a fitting name. Hi there. Programming Love Project insisted that blueprints were 50 times slower than blueprints, but you think it was a biased opinion? Okay, so blueprints were 50 times slower than C++. It also gives you bragging rights. Yeah, doing everything in C++ definitely gives you bragging rights. You know what? Now I really want to know. Let's try this. Let me find this might be the right window. Two others, you think that C++ is only faster when doing large math solutions in code. Yeah, I think it highly depends on what you're actually doing. I think that just because your actor is in C++ or just because it's in blueprints, I don't think this will really change that much. It really depends on what you're doing, and if you actually put the and this is actually this is, I've said this before. This is the way I like to do things. My actors are usually blueprints, but all the logic is in my C++. I do have in my C++ classes, and I just slap my C++ code as a component onto my actor. So the blueprint actor is basically only a shell that I use to conveniently just create my actors and then have them call all the actual code from the C++ component. Wait, maybe someone already did this. Let's try a quick Google search for Unreal Blueprint versus C++ performance. So, look at it. There's something at Reddit. How could it be wrong if it's on Reddit? So, before converting blueprints to CPP, he got this. After converting blueprints to CPP, he got this. Just a friendly reminder to nativize your blueprints to C++ if you're running into performance with your blueprints. There is no frame rate here. I'm only interested in frame rates. Draw cards. Well, what's this? You can make this. You can make this bigger to actually see something. So what does this tell us? World tick time. Look at that. I think the world tick time is pretty interesting. So the world tick time, before converting to blueprints, was using 22.09 milliseconds, and after converting it to C++, it's 0.99 milliseconds. Now I really want to, you know what? Let's try this. Let's just try this ourselves. So where is the project? Here's the project. So let's create a completely empty C. Let's just select everything here and delete this crap out. Actor light sources. Oh yeah, right. We do need light sources, right? Okay, I think I deleted too much. When you lock down, the world tick average is 29 in blueprints and 28 point something in C++. Oh really? Wait. Do I still have the screenshots open? No, but I still have the links. So counters tick cute 29. I'm not sure. You mean that one? Yeah, wait. This is call count. This is average is really close. Yeah, but these are different things. Those are not milliseconds, I think. I think the best comparison is frames per second. I mean, if I talk about performance, I want to know how many frames per second I'm getting, right? So, yeah, let's actually just these are leftover folders. Let's delete everything out. So, let's save current as, and we just call this test. Yeah, we just call this test. We're in content? Yes, we're in content. All right. So now we should have a test map there, which is like super empty. Save selected, of course. Do whatever you want. So first thing is we create where's the blueprint, and this is an actor, and this is our perf test actor. Do we put something out first? Let's see if there's just because, which I don't think. If just because there's, and maybe let's do another thing, because this is here's some huge performance boost. We're going to instantiate this thing for, I don't know, 1 million. Nah, maybe not 1 million. Maybe let's start with 10,000 or something and then work up. So you want to call something and set actor tick enabled, and you want to set this to not enabled, because if you have an actor that is spawned tens of thousands of times and even more, or this also goes for components that you're putting onto an actor that's instantiated or spawned millions of times. By default, they all have their tick enabled, which is called by default every frame. And even if the tick function is empty and it does nothing, just because it's being called and the engine has to manage, like, okay, this is enabled, I have to call this, now I call this, now it returned. This already takes performance. Performance you won't notice if you have only a handful of actors, but if you get in the tens of thousands, trust me, I've seen this. I've seen this here. I have a little. Unfortunately, our actors here are too complex to just put them into C++ in the course of this evening. But I have a performance test scene where I spawn like actually 10,000 of these game tiles. And the first time I did this, the engine almost stopped. It stood there and I got seconds per frame instead of frames per second. Because all the ticks were still enabled. And then I called this where is it? This set actor tick enabled and set it to not enabled for every actor and every component that's on the actor. And I got a huge 2-digit FPS performance boost. So, yeah, this is very important if you're planning on instantiating this many, many times. So we do this, and basically that's it, right? This is because we first want to see if there's actually a performance penalty for them just being blueprints, because maybe the engine has to handle them so much. So the first thing is we need to have something that actually spawns them. So let's also, for convenience sake, do this in a blueprint. Let's have another blueprint actor, and we call this our test spawner. And what are we going to do? We're going to have a for loop. Can I just do a for? This is a for each. Can I just do? I haven't done blueprints that much. Oh, look, for loop. Look at that. There's a for loop. Great. And we start at 0 and we end at, let's say, 10,000, right? Also, we give this thing a variable because we have to have a reference to the actor we're going to be spawning. So we add a variable which will be an object. Or, you know what? No, this can actually be an actor. This can be an actor. And this is actor to spawn. So, and then we drag this in here, and oops, this is get, and then we have spawn actor. It's somewhere down here, I know that. Spawn actor from class. Look at that, spawn actor from class, perfect. Can I drop this in there? Why can't I? Oh. Let's see if that works. I hope that'll work. Well, only one way to find out. Maybe it crashed. Collision handling override, always spawn, ignore collisions. Because we're basically... Yeah, we're basically spawning them on top of each other. I'm not bothering with giving them useful stuff. So, spawn transform, which is everything at 0 with a scale of 1, which is perfectly fine. Don't need more for this. Make this look neat and tidy to satisfy all the OCDs. And then we just put this in there. So, in theory, if we do set this variable to... So where can I... Oh, wait. Where can I set this to? Okay, you know what? We delete this out and we just select it here, which is our perf test actor. See? So let's just make it like that. Let's not make this more complicated than necessary. So we're spawning an actor based on our performance test actor, which is Paper flipbook actor. That's interesting. So our performance test actor, and we spawn it at 0, no rotation, no scaling whatsoever, and we should be getting 10,000 of them. So compile, save, drag the test spawner into the scene, and also set this neat and tidy to 0, 0, 0. Let's enable the stats like so, and well, give it a go. One or more blueprint has unresolved compiler errors. Yeah, I don't care. I just want this one. Okay, I'm still hitting a solid 60 FPS, so maybe we do need to spawn 1 million or something. Just let's just put 2 zeros in there. I mean, this is kind of a bad test because these actors, they actually do nothing. They just exist. Maybe... Yeah. Maybe we'd actually need more complex actors that actually have static mesh infinite loop detected. No, not infinite loop. Just a very, very large one. This is not an infinite loop. It's just a very large one. Oh, come on. Seriously? Why do you not recognize that this is okay. You know what? We just the problem is can I trick it? Can I say do this loop like 100 times? Or at least 10 times. I think I snagged 1 0. Let's say 100 times and then put another of those zeros out there. Oh, right. Yeah, the bot for the light isn't running because the streaming PC crashed. Because the streaming PC crashed on me just, I don't know, half an hour into the stream, and when I rebooted the streaming PC, I didn't bother to restart the bot for the light. But I can do this if you but first let's see if this gives us an infinite loop thingy again. So play. Let's see what that gives us. But yeah, the red light would be quite fitting. This would be kind of a red alert situation. But I know where I would like to try this. There is one situation where I could actually try if C++ versus Blueprints actually gives you a performance boost. The problem is it'd be too much for tonight for making it tonight because okay, I think we're not getting the infinite loop thingy. That's good. What does my CPU say? Well, not that much. Oh, infinite loop! No, it's not an infinite loop. Set actor tick enabled. Why do you think this is an infinite loop? This is not infinite. It's just a lot. Yeah, we're not getting it. Maybe we should actually do the spawning in C++ because in C++ Unreal Engine has no chance to like complain like, oh, this is, oh wait, completed. No, we don't need the completed thingy. All right. Because we're not doing anything when it's completed. Infinite loop would a nice infinite loop would be if I put the completed thing in there. That would be, I mean, look at that. That would be a nice infinite loop. So this loop starts this loop, and when this loop is done, it starts this loop again. This would be an infinite one, yes, but okay, let's maybe put 1 0 more there and 1 less here, but I don't think the engine will let us pass with this. So this test would actually be a bit more complex. We won't be able to do this just tonight. But yeah, as I said, there's one situation which is in our actual game. Actually, because these... Oh yeah, infinite loop detected. We find the first problems with blueprints. Yeah, you can't do huge loops. I mean, 10,000 did work. 10,000 worked. But if you make more, then I think it hits some internal emergency exit counter. I think internally it keeps counting, and if you reach a certain amount, then I don't know. Nico, hi there. A wonderful evening to you. And this is only begin play. This is not like it's on event tick or something. Yeah, maybe we should we need to do the spawning. And I think what would be a good test would be, because these game tiles, each and every one, if I eject out for a second, each and every one of those game tiles that can't be moved because they're immovable. Let me make that movable. Here, see? Haha, that looks kind of neat if you pull the tile out. These game tiles, they are blueprints. Here they are. This is our game tiles, and they are blueprints, and they are quite complex. There's a lot of stuff going on there. So recreating those in C++ is actually not really feasible because they are done by our artist. The thing is, they need to be blueprints because they are created by our artist, and he builds them nicely so they look cool and everything's nice. And but just for trying it out, porting at least the default tile over to pure C++. Oh, okay. Wait, I'm coming to this comment in a second. Converting them to C, because this is actually here. Denise said something like, you just checked in Google and there was a YouTube video of 10,000 characters ticking in Blueprint and C++. In C++, the person was getting around 70 frames per second. In Blueprint, he was getting around 5. That's very interesting because that sounds like a problem we actually have. That does actually sound like a problem we do have in this in this project at the moment. Because I can show you. Let me go in here and call the fill map instead of the generate map. And we're using, and also let's use the default tile instead of because the forest really kills it. The forest really kills it. So, if I run this now, this will take a while because it's actually spawning the 10,000. It's a 100 by 100 field, so it's spawning 10,000 of these actors right now. Takes a bit of time, and there is one very interesting effect that I don't have an explanation for yet. So let's enable the stats. And we see I get about, not sure how good you can see this. At the moment, I'm getting around 16 16 frames per second. If I zoom out a bit, it's only getting worse. Whoops. Yeah, so I'm hitting about 15 FPS. Oh, and my GPU is actually at the limits. Okay, this is interesting. Yeah, this is when you want to demonstrate something. Okay, that didn't work. Maybe I do have to use the forest. Let me try this again and actually use the forest. Maybe this was so. That would also, but that would mean that your actors actually have so spawning the empty actors would have actually yielded nothing. So getting this infinite loop error is not that much of a problem, because spawning those empty, because these actors were quite empty. There was not much going on, and I think the frame rate limit was actually my GPU, because the GPU hit 100% load. So the actors actually do have to have something. Because if I use the forest tiles now, if it should ever finish spawning them, this is going to be a huge forest now. Eventually. Dum 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 boom boom boom. Yeah, it already takes some time spawning them. So the problem is porting these tiles over to C++ is a lot of work, because they are quite complex. Yeah, okay, considering the kind of GPU I have here, because look at this, I'm getting like 4 FPS here, 4.5 frames, and the editor does actually have. I'm clicking into the editor, so the editor does have focus. Because the editor dials down its resource usage when it's not in focus. And the interesting thing is that neither my CPU nor my GPU are at full load. Considering the GPU is a GT 750, without an X, it's not a GTX, it's a GT 750. So, and even that one's not completely fully loaded, and the CPU isn't, and I'm still only getting like 4 FPS. This might, in theory, based on what Denny said so far, might be caused, maybe, huge maybe, I have to try this out. This might be caused by the overhead added by the blueprints, which would be bad, because, as I said, these actors are created by, it's also nice having so much forest. Look at that, all the forest. And you can build roads through the forest. Well, you're not seeing much because of all the forest. These game tiles, these actors are actually created by our artist. So porting them completely over to C++ would be impractical, because then our artist would not be able to edit them. And the problem is, a lot of things have to be edited. Did I hit stop? No. So I can just show you, because if I open up the blueprint, Shino, hi there. A wonderful evening. Greetings. So because there's, you see these selection material scene components here. And for each selection material, you have to choose the materials that are, okay, this is I have to hit stop here in play mode. You can't see this. And apparently he said nativized actor for blueprint. Don't know what that is, but he was getting really close FPS. Okay. That sounds interesting. Nativizing blueprints, Unreal Engine documentation. Reducing VM overhead. Aha. This is something I have to check out. To be aware that when you do your executable size will grow. Yeah, that's okay. Huh? Your executable size will grow to a size that may be unacceptable for the platform that you're shipping for. Ah, because it's compiling everything in or what? That's interesting. Okay, this is something I have to take a look at. I was getting closer to C++. Maybe that would actually solve our problem. What's that? Or can I... Okay. I have no idea what that is, but I want to find out. Enabling. Do I just enable this and it works? We could just try this. Yeah, the problem is why it would be impractical to actually implement all our actors, at least the ones that are spawned so many times in pure C++, because our artist has to place all these meshes where he wants them to be, and then there's the selection material thingies that, oh, because it's hidden because it's here. Oh, do they only have one material? Oh, that's interesting. Because for every material each mesh has, there is a selection material, which is when let me make this the normal map, so we actually don't get that performance hit. This shouldn't take so long. Okay, see? So when I hover over one of these game tiles, you see that the game tile changes. So it gets this pulsing blue glow to show, okay, this is the tile you're currently highlighting, you currently have selected. And there's a special material that's applied to every mesh. And for every mesh, for every material every mesh has, our artist can select a special selection material that replaces the actual material of the mesh for the highlighting process. And when you unhighlight it, the original material gets restored. Yeah, and he also has or wants to place all the separate meshes, and this is all things he would not be able to do if I would implement these actors in plain C++. So we kind of have to use blueprints. So let's see if this is just an option that you can enable. Let's see where that was. In reducing VM overhead, the main goal, blah, 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 blah. Okay, I have to read this. I don't want to sit here an hour and you look at me doing nothing while I'm reading and trying to understand this. But I definitely will look into this. So we have to meet again and talk about this. So what do you first to create a project blueprint is disabled by default. Locate project settings, packaging. You should be able to set blueprints. Okay, the question is this only done in packaging? Because then you would not be able to try this out in the editor. I would have to actually package. Well, we can do this. So let's try this. So project settings, packaging, project blueprints. Blueprint nativization support. Okay, what's inclusive and what's exclusive? Enables for selected for selected assets only, for all blueprints. Okay, let's say all. I don't think this will have any effect in the editor. Yeah. Didn't think so. You know what? Let's make the hardcore test. Let's enable this again. And execute console command. I think it's stats details. No. You know what? Let's try it with the other one first. That doesn't take so insanely long to. I think it's stats details. I have no idea. Might be. Okay, now I had it open anyways, so. And also this is not really showing the details. This is only FPS only. So stat hide all. Let's see if that enables them. Yeah, this is something I think I have to spend more. Yeah, this didn't work. Come on, what was the command? I had used this before. Unfortunately, we've... Oh, wait, maybe... Wait a sec. Maybe the old blueprint still exists. Haha. Was it here? Da! Stat detailed. That's the command I was looking for. I was close. Stat detailed. So that enables the stats display. Yeah, great. So we got the FPS. You see, I got really lousy FPS on this machine. But this is because my laptop I'm working on is not that powerful. It's 6 years old. I'm still happy it's still alive and working at all. So you know what? Let's just try and actually package this. And I think the stat details, at least to some degree, also worked when you build this in shipping mode. Yeah, shipping. Okay, this will take a while, because building always, well, takes a while. But while this thing builds in the background, we can talk stuff. We can just theorize what else might happen. Yeah, but this is actually a quite good question that I'd really like to get answer, and I can really only answer it if I try it out myself, which I will do. I will. Oh, Jesus Christ. I will make up a little benchmark scene where I spawn, like, I don't know, 100,000 actors that are blueprints, 100,000 actors that are that are C++. But I think they all need to have something, and they all need to do something. So just spawning empty actors, I think, will yield nothing. And I think it's the overhead of actually all the components being handled. Well, it would make sense. It actually would make total sense if the blueprint, but that much? Interesting. Interesting. See, this is why I like having you guys here, because you always ask the interesting questions. You always ask this stuff where I really go like, damn, now I want to know. Yeah. Yeah. We'll be coming back to this. We'll be trying this. Maybe this already gives our package and failed. Okay, I don't know. What happened? Trader component 1 has inappropriate outermost. It was probably saved with deprecated outer far. Blah, 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 blah. Yeah, okay. I don't know. There's something. Okay, we won't get this answered today. Yeah. Trader component 1. Huh? Inappropriate outermost. Where the heck did it save that? Because yeah, I think this actually does not exist anymore. No, it does. It still exists. It complains that this thing wouldn't exist or be invalid or anything, but it's still there. I don't know. I actually changed a lot. I actually moved some files around and did stuff. This is something else I need to figure out and fix. Yeah, sorry. We're not getting this answer tonight, unfortunately. Or maybe maybe we could do it the other way around. Huh. Maybe we can do it the other way around. This is another thing I wanted to take a quick look again with you guys. Because this is something we did in the course of this tutorial series as well. This is the little game of life implementation. So if I hit the enter key now, that Devcom logo will go away. It will evolve and eventually most of the cells will die, which is kind of sad. And these are C++. Maybe we could do it the other way around. Maybe we could have it spawn. Where's our spawner anyways? Where is the stuff being spawned anyways? Where's our... We need to have some basic baby... Oh, we put that into the... we did put this into the game state, right? Yeah. Oh, even the method spawning everything. Of course we did it in C++. I mean, this was a C++ tutorial. But where did it get the information of... Oh, because this is... Okay, yeah. Okay, yeah. You can, of course, you can reference you can reference a C++ actor from a C++ class. We can't just use our game of life implementation to try this out as well, because all the code is in C++, and in our field handler that actually spawns all our actors here in our init field, we have we have the spot where we spawn all the actors, which is quite easy because we could say cell actor, where's that? We set this to something. Where did we set this to something? We did set this somewhere. Oh wait, maybe we actually did put this in the editor. Field handler. Oh yeah, cell actor. Maybe we can use this to try, because this already spawns like, I don't know. Let's make this a one. Can I select this properly? Let's make this a 100 by 100 field or something. Or even, no, this is okay. So run this. Take some time again because 10,000 pieces. So see, this is a huge field of these things. And let's enable the stats. So. And I'm already only having, well, it's not too bad. Depending on where I look, if I look up there, I got like 20-ish. No, it's close to, it's borderlining 30 frames. And if I just look down here, it's going up to 40. So it might actually have to do something with my graphics card just being overloaded, rendering all those meshes. But this is basically 10,000. Like, look, we numbered them. Selector 1, 2, 3, and so forth. So yeah, this is actually 10,000. So we could actually make more. If 10,000 still performs that well, let's make this, I don't know, 40,000 or something. That should tank the frame rate way more. And then we just make a small, yeah, let's try this. And then we make a blueprint. Well, see, this is, yeah, maybe this is a bit much because we're expecting it to get slower. So let's keep this at a 100 times a 100 large field. So, and now we create a blueprint actor. And we also give this, I just want to open this. Did I accidentally drag this into the scene? No, I didn't. Did I? Test actor, global, blah, 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 blah. No, okay, cool. So let's also give this a few static meshes, just so it has something to do. Maybe this is what's causing the overhead. Let's also add 2 of those. One will be our cube. And the other one will be the sphere. That's the 2 meshes we used for these things. So, I think, wait a second. I think to get the desired effect, I have to move this to there. Yeah, let's just try this. This is okay. And let's say this is our test actor. There it is. Compiled and saved. Oh, this is... Wait, did I call the... On our C++ actor, did I think I did the tick enable, right? Yes, no. Here's our actor. And where's begin play? Where's the begin? Begin play. Oh, wait. I didn't even disable the ticks. What the? I really didn't? Why didn't we do that? That thing doesn't have a begin play. Oh, there. There it is. Begin play. Oh, this is interesting. I'm not disabling the tick. This might be one of the reasons why the frame rate is tanking so much. Okay, this is interesting. So I won't disable the tick in the blueprint as well. And then we try it with tick disabled on both occurrences. Yeah, but this should be it already. Let's try this. I'm not sure what frame rate did I get? It's a bit less. And also the sphere's on the wrong side. Let me just quickly fix that. Let me just move the sphere over there. And try this again. Yeah, this looks like more what I expected. Okay, 22 frames, of course, because there's more meshes. What's my GPU saying? GPU is, yeah, actually ceiling at a 100%. Maybe we need more. I need so many actors, and maybe it's a bit unfair to actually have both of them shown. Can I just disable? Yeah, it needs to be fair. So we delete the sphere. No, wait, we don't. We delete the cube, or at least set the cube to. Can I just set this to not visible, only in editor? Hidden in game, not visible. Look at that. So. Because it really needs to be fair. So if the C++ thingy is only spawning spheres, this one's supposed to be only spawning spheres. And also let's fix the scale. Because the sphere has a scale of 0.25, which is also a thing the underlying math of game engines doesn't like. Scales with decimal values, non-integer scales, they really don't like this. This also gives you bad performance. Okay, this definitely didn't work like expected. So 0.25, 0.25, 0.25. And of course this has to be at the 0 location. So are we already seeing some performance difference? I think slightly. Let's try more. Let's try like, I don't know, 150 times 150. Let's see how that works out. So, below 60 FPS, just looking forward, and looking up there, I'm going down to 16, 17-ish. Let's replace this with our C++ actor again. I think cell actor it was called. Yep, there it is. And this is even worse. Okay, I think this is kind of an unfair. This is even worse. The C++ actor is. But why? It's interesting. Does it? Yeah, it has a few more. It has a few more things. Yeah, well, but not that much. Interesting. Yeah, no, I think this isn't a fair comparison because the actors are so different. Static mesh component. It doesn't do anything in the tick, but besides calling its parent. Huh. Yeah, I don't know. Maybe our C++ actor is still doing a bit more stuff than the blueprint one. Yeah, I'm sorry, guys. We're not getting a really scientific answer to this tonight. But I will pursue this. I will try this out. I think what I'm actually gonna try is I will recreate one of our actual game tiles from our game. I will recreate this completely in C++. So it works absolutely the same. And then I will see how things work. Yeah. And also I will check out the nativized blueprints thingy. What exactly that is and how exactly that works. At the moment I'm like super confused that our C++ actor actually gives us such a bad performance, and the blueprint actor actually gives us so much. New consideration: your C++ is less optimized than blueprints. Well, the problem is, usually I would absolutely agree with you, but there is not much to optimize, because once the actor has been set up, it's actually doing nothing. The thing is, once everything has been set up, it's actually doing nothing. Well, what it does do, maybe we should comment that out. It's actually binding to this event. Let's remove the binding to the event. Maybe that takes some time, because the event handling and shouldn't, but who knows? Because all it does is it just sets up the actor. It creates a empty root component. It creates the static mesh component. It slaps one of our meshes onto the static mesh component. And that's it. That's it, period. It's not doing anything more. And because all of these things are only called when, well, something's called. The only thing I didn't do here, but I also didn't do this in our blueprint test actor, I did not disable the tick function. But then again, maybe it knows this one's empty. So let's try to make this. Let's in a desperate attempt to get this comparable. Let's set the tick enable to false here. And let's set the tick enabled to false as here as well. Set the actor tick enabled false. So let's see what that gives us. Maybe an error because now there's an unused variable. I'm not sure how. I think the compiler doesn't like unused variables. The checkbox wasn't marked. Exactly. This is exactly like I wanted it, because the checkbox not being marked means enabled not being ticked. The enabled not being ticked is basically disabled. So this would be true, this would be false. And I actually want to set this to false, which is exactly this one. So yeah, this is a bit confusing, because I'm calling set actor tick enabled, and then there's the enable thingy, but I actually want to disable it. So yeah, this might be a bit confusing, but well. So just to make sure, let's compile this again, because the hot reload. So let's try this. This still spawns our C++ actor, I think. And look at that. I'm not sure if this is. See, this is the problem. We've changed two things at the same time, and if you're looking for something, this is something you usually don't do. But the two things I did now was I disabled the tick, and I disabled the binding to the event. So if I click them now, nothing happens, because I removed the binding to the onClick event. And if I look up there, I got like 17, 16-ish FPS. But that might be my graphics card. Yeah, that's my graphics card. So this is, yeah, still not really comparable, because I have such a potato computer. I like you. Don't be mad. I still love you. You know that. It's a good computer. It's just not a 3090. Let's set this to just for trying this out to our test actor. The problem is I need as many actors spawn so that my graphics card isn't the bottleneck anymore. Maybe we actually need to pump up the volume and to spawn more of those actors. $52, $51-ish. 18, 17 FPS. Yeah, we need more actors. It's easy. We just need more actors. We make 250 times 250. This will completely kill my machine. This will completely kill it. Also, it will take like ages for them to spawn. Yeah, I think you need a better machine where not your graphics card is the bottleneck, and B, more complex actors to actually try this. But trust me, I promise you, I will. I will make up a benchmark test demonstration project, and I will find a way to share this with you. Actually, I will definitely share this on my Twitter. So feel free, here, shameless self-plug. Feel free to follow The Real Hellcat on Twitter. Because once I've done this, once I've made up a set of comparable actors that are complex enough so there is actually a chance to get enough overhead, I will post the results. And not just like in the, not that I don't believe this, the YouTube video Denis mentioned, but I'd actually like to show you. So once I posted that I do have the answer, it's just a matter of time till we meet again. And then I will show you. I will demonstrate it to you for science. We will make science. We will make science happen. We make Unreal science. Yes. Many people make games in Unreal, and we do science. So, look at that. My GPU is not at 100% now. My GPU is at, well, it's at 90%. It's at 90%, but looking down here, it's at 100. So, this starts to become an area where not my GPU is the bottleneck, and I'm actually not sure which one did we... This is the test actor. Okay, this is the blueprint one. Maybe we need even more. Maybe we need even more actors, like 500 by 500. I don't know. We're completely cannibalizing this poor little Game of Life project for science. Yes. For science. Ciencio. So this is the C++ actor, and looking up there, same result. Same result. 7 to 8 FPS. And graphics card only at... Okay, one last desperate attempt, and then it's time to part ways anyways. Let's completely trash this. Let's make this 500 by 500. This is the cell actor, which is our C++ actor. Go. So this is one last desperate attempt of at least getting a direction to an answer. I'm not promising you we're finding an answer tonight, because we won't. But I'm hoping to maybe get a direction. But again, I promise you, I will make a little test project, a little test and benchmark project, where two things for science. I will try it out, And I will also make the test project available for you guys. Which also, by the way, the Game of Life thingy. I'm not sure if you know that, if you followed at least the last session where we made it. This little Game of Life implementation, it's also available for you to check out. Where is it? I got the link somewhere here. If you want to take a look at this, because we made this, I think I'm going to reverting everything. This is the wrong window, but the right one is still busy. Let me fire up. Where's my? Now I lost my mouse. Let me fire up my. No, just to demonstrate what it is, I can do this by resetting the field size, and then now it's really busy. Haha, now he toasted it. Haha, yep. Oh, my memory's... I'm also running out of memory. Okay. Yeah, Unreal Engine does this because reasons. And also I got quite a few Rider instances open there, but wow. Burn, baby, burn. Yeah, absolutely. It's still spawning. I can't get the window. What I can do, I can use this window peek thingy to look into the window. But if I click it, I can't get it into the foreground because it's still it's locked up. It's completely busy. If I look into my task manager, it's even telling me it's not responding. Well, we're gonna be waiting this out because I want to see this. I want to see this going up in flames. This reminds me at the dog sitting in this completely burning room, and this is fine. Everything's fine. Everything's normal. It's still busy. See, it's not detecting an endless loop now. So who's endless looping? Okay, at least I got the window. Look at that. So this did something. We got 25-ish frames. Cell actor. This is our C++ actor. Giving us 25-ish frames, just looking straight ahead, not looking at them all. And my GPU is not at full load. Look at this. My GPU is only at... this is... I need to have this in focus, but then we don't see this one. So it's 70-ish% load. Let's try this again. Because the result we'd expect, if it's really the blueprint overhead, because now it's not my graphics card that's limiting the FPS, because the graphics card is not at 100% anymore. And this is basically the state I wanted to reach. And this is the C++ actor. So if we now switch over to the blueprint actor, we should get an even worse frame rate, because since now not the graphics card is the limiting factor here, if there's any overhead, I mean, come on, this is 500 by 500 actors. This is, how many is this? This is 25 million? No, 250,000? 250,000? Yeah, something like that. No, 25,000? 250,000? No, I don't know. So let's go to the game state and let's use our test actor. So this is really the last desperate attempt, and then I will let you slide into your well-deserved night. And we only have one day left until it's the fine weekend. So yeah, the Game of Life, by the way, for those of you who don't know, we did this. It's a little implementation of Conway's Game of Life. And we did this in the course of 250,000 was right. Yeah, it's a quarter of a million actors. That sounds nice, right? 250,000 sounds like, yeah, it's 250K. So what? But 250,000 actors, that sounds like something. imagine I'd get $1 for every actor I'm spawning. That would be nice, huh? Yeah, I could get it. I could get a new streaming PC, one that doesn't freeze. Yeah, great. I like it if it doesn't freeze. Wow, do I sound differently, or is it because I just rearranged my headphones here? Yeah, Conway's Game of Life is you have these actors we're currently spawning. They are actually supposed to be cells, living cells, and if they are those at least in our implementation, when they are those little spheres, they are dead, and when they are those huge cubes, they are alive. And this really sounds different. Do I sound different to you, or do I just sound different to me? The game calculates generation after generation of these cells, and it checks if in the next generation a cell is dead or if it's alive. It's not Schrödinger cells, it's Conway's Game of Life. So they are not dead and alive, they are dead or alive. Like in the Wild West, no, wanted. Dead or alive. Schrödinger's Wild West, wanted, dead and alive. And depending on how many neighbor cells that one cell has, either living cells die off because of loneliness or overpopulation, or they keep living because they have the perfect neighborship, or dead cells become alive because of reproduction and stuff. And we did a little implementation of Conway's Game of Life in the course of 3 evenings of this series, of this tutorial series. And it turned out to be quite nice. You have these cells, you can click them once this we let it go up in smokes is over. I can try to demonstrate it last time. So you can click on them to make them dead or alive, and then you hit the enter button, the enter key on your keyboard, and it starts calculating generation after generation after generation, and you can see your cells evolving, moving, dying, coming back to life, and so forth. And the source code for the whole project is available for you guys to check out if you want. If you missed it, if you want to check out the code of this Game of Life implementation that we did here doing this tutorial series, I just threw the link to the Git repository into the chat. So if you want to check this out, no pun intended, checking out in the sense of looking at it or checking out by literally doing git checkout, no matter what you want. If you want to check it out, there's the link to the Git repository. It's completely up for grabs. Take a look at it, play with it, change it, do things with it. Yeah. So if you want to, there it is. And if you don't want to, just ignore the link. Yeah. Just wanted to get this out in case you missed it. There's the link to the complete source code. I don't want to get this behind anything else. So I can't click into the browser and show you stuff because then that thing goes away. But yeah. Here's the whole project. So you can literally just check it out, double click the U project file and open it up in Unreal Engine and compile it, give it a try, play with it, change things and try things out like, what happens if I change this to that, or what happens when I change that to this? Yeah, whatever. So eventually this should finish spawning. We should have actually timed how long it takes to spawn them. Maybe even spawning the blueprint actors takes some more time already. Who knows? Who knows? Get it? I would actually really like to try this out with one of our Let Them Try tiles. Because I think for this overhead to actually have a measurable effect, the actors actually have to, I think they have to be a bit more complex than just an empty actor with a cube or a sphere. I would actually like to try this out with like the forest, but the problem is there's so many separate single meshes. Maybe the problem is I really don't want to have this window going into the back. I really want this to stay up front, so I can't click into the, but I want to this nativized blueprint thing. I definitely have to check this out. And once I'm at a point where I can at least pretend I understood it, we can talk about this. I can just look back on the stream VOD and figure out the spawn time. Yeah, I can do that. Oh, you're right. I could do that. But I think in my little benchmarking project, I will just put a timer in. It will just time it by itself. And again, the actors need to be a bit more complex, like having 4 meshes and maybe having a component on them. But the component shouldn't impact it that much, because at least in my case, the components are C++ anyway, so I don't have a single blueprint component. The components are all yeah. But this is very interesting. I really want to figure this out. If so, how much overhead there is in blueprints. I know that they did something. By the way, did they in that YouTube video that showed the difference of the C++ implementations being so much more performant? Did they mention the version of Unreal Engine they were using? Because if I remember correctly, they actually did something to the underlying blueprint engine in one of the more recent updates. I think they changed something. I think in one of the change notes, they were actually quite proud to say, hey, we also reduced the performance penalty when using blueprints. Blueprint performance update? I don't know. Performance guidelines for artists and designers. That's also quite interesting. I might want to read into this. Yeah, I don't know. I could also maybe they I don't know, maybe I'm confusing this with someone, but I think they said with some update they actually worked on the performance of blueprints. I think they were actually quite proud, saying that the performance of blueprints now is not that much behind of native C++. But maybe it's this nativizing thing. Maybe they were talking about this nativizing. I really have to figure out what's wrong with our project. I really need to manage to make a build of our game that's working. Not sure why it complains, but yeah. I did move some files around, so maybe it's actually still looking at something. Maybe it's looking at a blueprint that actually is in a different directory now. So, but I gotta fix this, and first I have to find. But it's still. Is it just me, or is it actually taking longer for all the spawning stuff? This is why you should put this into separate threads. Yeah. Yeah, I don't know. Maybe just one of you know a bad joke or something. I only know. Well, I got a math joke, but I think maybe we covered this on one of the Wednesday sessions. No, I think I already told this one. It's boring. It's quite busy. And we are quietly busy. Yeah, that thing's quite busy and we are quietly busy. A subtle but important difference. Well, this thing, I think I already killed it. It just does nothing. It just hangs there. That's the video. Okay, let me see. Did they? August 2017. Interesting. So yeah, it's some older version featuring multi-threaded tick. But anyways, thanks for the link to the video. I will definitely look at this. I will definitely watch the video and see what they're saying, and also maybe there's something interesting in the comments. We're definitely gonna be pursuing this, and yeah, I'll be talking to you guys about this. This is taking so much time to spawn the actors. Does anyone remember the frame rates I got when using the C++ actor? It's taking so much time for the spawning. I even forgot the frame rate I got before changing the actor to the blueprint one. Ah, here we... Wow. Ladies and gentlemen. Oh no. The editor didn't have focus. Too bad. Yeah, no impact whatsoever. I think I got about, about 25. Yeah, and we're still getting about 25. Absolutely no difference there. And the same with the GPU, it's about 75-ish%. Yeah, absolutely no difference. But this doesn't have to mean anything. Maybe this actor is just not complex enough. Maybe this actor is too simple. Well, I'm gonna completely kill it when I look up there. Oh yeah, look, now it's actually seconds per frame. Do you see this? It's actually seconds per frame. Maybe these actors are too simple for the overhead to actually come into effect. But then again, I mean, this is 250,000 actors we have here. I mean, I can't even scroll this list because it's so huge. Well, I can kind of scroll. Look, here's 249,999. Yeah. Unfortunately, this didn't have any effect. This can have two possible reasons now. Either they actually really did something to the underlying blueprint engine, so there's not that much of a performance penalty anymore when using blueprints. Or these actors are just too simple for a significant overhead to actually have any at least for us measurable, or without diving deep into the profile and everything. Yeah. But the interesting thing is, and this is exactly the problem that I'm still facing with our actual project, and I'm still hoping to find someone who can at least explain this to me, so I'm able to maybe find a solution. Because look at the frame rate. I mean, the frame rate is really in the trash can right now. But the thing is, neither my GPU nor my CPU are at full load. The GPU is currently at 60%. My GPU, and this is a really potato GPU, is at 60% of load. So there's still 40 more percent it could be doing, but it's not. My CPU is sitting at around 40% with everything else in the background open. So there has to be a different bottleneck. Something is causing a significant performance drain there. something that's not caused by CPU or GPU load. And I have no idea what this is. And this is exactly the problem I'm getting when I showed you the test call with the huge forest field, with the 100 by 100 play field of forest. I'm getting exactly this symptom. The GPU is sitting at, like, I don't know, depending on your CPU, it's sitting between 20 and 50% load. The CPU, it's completely bored, it does nothing. But yet the frame rate is in the lower single digits, without anything that you can see in the task manager being at full load, or even remotely at full load. And that's the part I'm not understanding. And I'm still looking for someone who can explain this to me. Hey, who can tell me, yeah, this is because reasons. Yeah. Because I have no idea where to start looking to figure this out by myself. But should I figure this out, this is definitely worth a talk on the next conference. Absolutely. Well, my friends, with that said, wait, I wanted to show you the game of life in action, the actual game of life. So, should you try to check out the actual code? Oh, and now I can even go in here. Look, when you go to source, game of life, the game. This is our cell actor we just had open in the IDE. So this is the actual code there. Have fun looking at that. Of course, now it's taking some time to clean up, but the cleanup and throwing away all those. See, this doesn't take that much time. So let's go back here. Let's make this our proper cell actor again. Let's make the field again to, I don't know. Let's make this. I mean, I just want to show you how the game works. Let's make this 50 by 50 or something. It's the cell actor. Let's also re-enable the cell actor because we remove, this is the wrong window. Because we removed this one and we actually need this, or else we can't set our cells to the alive state. So compile and run. This shouldn't take that long now. This should be fairly okay. So, why is the play thing? Oh, because it's still compiling. Okay. So now I should be able to, yeah, look. So the game of life thing is basically, as I said, when it's these little spheres, the cells are dead, and when I click on them, they become these not so little squares. And let me, I think it looked like this. And then there's something pretty nice because then we can put this down here. So these two I like to call blinkers because they're just flipping around. They're just changing status, but they're kind of stable. They will stay there forever. This little cube down here is super stable. That won't move at all. This will just stay there forever. And this is a so-called glider because the cells will evolve in a way so it looks like this thing's moving down here. And when it hits this cube, it looks like it explodes. So let me hit the enter button and see. These just flip around. That thing is moving towards that thing. And once it hits it, it'll look like it's exploding. And basically, it's just the new generations of the cells being done. There's a bit more to it. You can have the fanciest of all patterns. Like, I don't know, you can do really crazy stuff. There's actually on Wikipedia, if you check out the Wikipedia page for Conway's Game of Life, you will see there's many fancy patterns that look nice and you can have running and look at. So here's our little robot face. let's see how that evolves. That looks quite funny. Yeah, and it's kind of going on, and I think it's even for a moment there it looked like it was stable and was staying there and flipping around, but oh yeah. See? So that's Komai's Game of Life in action. We've done this over the course of 3 evenings here on the Devcom Tutorial series, coding for Unreal Engine in C++. It was a pleasure and a great joyride. It was a great 10 weeks with you guys, and the Devcom team is already playing new formats and new shows. So stay tuned. Stuff will be happening. We will be seeing each other again. If you want, again, shameless self-plug, follow me on my Twitter or my Twitcher. So we'll definitely be able to meet there. And if you don't want to follow me personally, then stay tuned, because there's a good chance we'll be seeing us again right here on this channel, and maybe even on Thursdays. Who knows? Guys, thanks so much for being here with me for all those weeks. I know I've said it already, but please bear with me. But I had such a great time. Thanks again. And, well, be well and see you around, right? The next time on my channel und dann auf Deutsch. Genau. Bei mir auf meinem Kanal ist es meistens in nicht ganz so Englisch. Geht auch in Englisch, aber meistens machen wir es auf Deutsch. Alles klar. Ihr Lieben, da ist der Knopf. Ich wünsche euch was. Ein wunderbares Wochenende und wir sehen uns. See you around. Have a wonderful weekend. Smell you later.